Mike Cohen. Mike is a renowned digital forensic researcher and senior software engineer. He's developed and supported leading open source DFIR projects for over 2 decades. Mike is our digital paleontologist and brings his years of experience to the role of principal developer of Velociraptor. I do note, however, you are not a Velociraptor like one of our speakers yesterday, but that's okay. We'll go with it. All right, Mike, if you come on mute, it's all yours.
Oh, thanks very much. Can you hear me? Is it working properly? Or?
Yes, we can hear you fantastically.
We have the NBN, so you never know if it's going to work or not. So thanks for the opportunity. So yeah, I didn't have a lot of time to prepare, so I just thought we just have a bit of a play with Velociraptor, and I'll just give you a bit of an overview of what it is and kind of what we're trying to do with it, and we'll work through a case study that's, I mean, I can't actually give real data, but similar to a case that we were doing, a few weeks before the world ended, kind of thing. So yeah, basically, I didn't really prepare any slides because I just thought I'd just show you the interface and we'll just work through everything. Look, I just kind of wanted to show off some of the new features, which include the notebook. So I just kind of drew up a quick notebook, which will be the introduction. And so when we first, so Velociraptor, and the reason that I titled it DFIR Beast Mode is because I just realized that the other day when I was using it that it just makes us so much more effective because we can operate at such a large scale that it just felt like you are, playing at the top level of the game and winning, right? So that was pretty cool. So I like this picture because this is kind of like the Velociraptor on the shark with the gun. We're really kind of doing well. And then there was this KXCD. Which sort of tells you, if the Velociraptor is going to run towards you at, so many meters per second. Quickly calculate and, figure out how long you'll survive. And I would like to think that, this is the Velociraptor, chasing the bad guys laterally moving across the network and figuring out how fast can they move before we catch them, kind of thing. But anyway, yeah. So Velociraptor. So basically, this is the overview of the high level overview of what it looks like, and so we can see that we have I'm not sure, is this actually, no, okay, so we can see that usually we deploy Velociraptor server in the cloud on a VM instance, and then we have a whole bunch of assets which are like laptops or endpoints or various things that have the Velociraptor client agent installed, and then it has a persistent CNC to the server, and so we can actually query the endpoints on demand. So because it's persistent, we actually have because it's a persistent connection. Then as soon as we launch a query, it just replies immediately because it's all ready to go. We don't have to poll. There's no kind of lag there. And then we have the admin UI here, which is how we basically use the application. This is the application I'm using right now. And so we can see how that looks here. So maybe make this a little bit smaller. Okay, so this is kind of what it looks like. I'm just going to just say this now, but I will just go into it more details. The thing that makes Velociraptor really special is that it's really just a querying engine. So there's a query language which is implemented by the front end, the servers, the clients. They're all basically just a query engine. So it's very similar to SQL if you're familiar with SQL, but essentially imagine that you can just simply launch a particular query on all your endpoints and get all your data. So you can treat your entire deployment as a database, and that's not a new idea. We have OSQuery and other systems like that. But but basically, because the query language is very flexible, then we are able to actually achieve quite a lot more. And I'll go back into that a little bit later on. So I'll just start off by having a look at the top level, the dashboard. And as you can see, the dashboard here is the main, so this is just one of our training machines, of course, so it only has two endpoints connected to it, but we will typically have about 5 to 10,000 machines, maybe connected to a single server, and so we just have these monitoring telemetry of the server, so we can see how much memory it's using and CPU load and things like that. And over here we have, how many clients are connected. And over here we can see how many the users that are enabled on the system. And we have different roles. So we can see that Mike, which is me, and as you can see here from my login up here, I'm the administrator, so there are no restrictions, but you can have like an investigator and analyst, and so there's different types of roles that we can have. So this is basically, just kind of like an overview of the server, just to see what it's doing. But the real power of it is when we can essentially look at the different, just refresh, at the different endpoints, and I don't know if my internet's working. And you can see that we have a number of different endpoints here, and this is just one of our training machines. We can label them, and so we can label and target them depending on labels. But we basically have a persistent connection to this machine. We can select it. We said it is connected, which means that we can essentially task it immediately. If I go to the VQL drill down, that just tells me a bit more information about this endpoint. So we collect continuous telemetry about the endpoint just because we want to know how heavy the machine is on the endpoints, how much memory we use, how much CPU we use, that kind of thing, depending on what we're doing. As you can see before, I was doing some collections, CPU load jumped up, it collected some stuff, and then it went down. So we can actually account for our usage, and we can see what user accounts are on the system and so on. Now I'm going to show you, this is what we call the VFS view, which is the virtual file system, and it's very familiar because it's, everybody's used Explorer, and it's very familiar to be able to just kind of browse the file system of the remote end. And you can see that, but this is really just a cached information about the file system of the endpoint on the server. So it doesn't have all the information. And if we want to get more information, we can click this button here, which is the refresh the information from the endpoints. And it will just go out to the endpoint and grab a new file listing, for example, and then you've seen it just appeared, right? So it basically just refreshed that view of the server, and so I can now go in there. But of course, each one of those will not be filled out either. You can click the recursive one to just recursively fill it all up. But what actually happened when I clicked this button, you saw that it fetched the data from the server. If I just have a look at this menu collected artifacts, and this basically has a list of what we call artifacts. So I just wanted to introduce this concept of artifacts. And you can see that as I navigated through the VFS, then I'm collecting an artifact called system VFS list directory. So that's essentially the artifact that is listing that directory, that is showing me the directory listing gets populated in the UI whenever I click on this thing. And so as I go through, it issues one of those. So for instance, like you remember just before, I clicked refresh when I was in the Windows directory, and so it essentially filled in these parameters, collected this artifact, and off it goes, right? So this is actually quite an interesting idea, because everything in Velociraptor is just an artifact. So if you can see in here, for instance, this is the request that went out. We can see some VQL, and we can see the results. And because everything is a query, it's just a VQL query, then it returns results. So it's just like a database. You're going to get back rows and columns. And the VQL, as we can see from the request, this is the query here, is actually, it's determined by the artifact, and then it just returns back a table of results. And then over here we have the log, which is the query log. So let me just get this out of the way. Yep. And so over here we have the query log, which is the list of basically log messages that are emitted by the endpoint as it's executing the query. So it's telling you, like it started at this time, it ran through, it sends the response, and of course, because it's a query, the response is just a bunch of rows that it sends back. So it sent 107 rows in this case, and it just all went back. So it's really just a CSV kind of going back and forth. So this is kind of interesting, and I just wanted to delve more into showing you what it looks like. If we look at this menu here, which is the view artifact, so I mentioned the VFS artifact. And if we search for the VFS artifact, you recall the system VFS list directory is the one we looked at. In this view, you can see it's just like an inspector of the artifact. So we can see the VQL, the query that's actually issued. And you know, the query is just a straightforward query language. I'm not going to go into too much detail here other than just, you know, just to point out that it's basically a select, a from, and then a bunch of columns and potentially a where clause and so forth. And that's really cool because it means that essentially the endpoint is very flexible. We can actually change this. We can add new queries. We can issue new queries on the fly, and it will basically just do them all the time. So I just wanted to now just to give you a bit of an example of how we would use this. Let's say that there was an alert. For example, an alert would have been launched on one of our other systems to say, you know, oh, there's a suspicious incident happening. So I'm just going to switch over to the notebook. And this is kind of a new feature. Notebooks are designed to help you document the investigative process and just work through the evidence, and we'll work through that because it's a nice exercise of how that works. So let's have a look at this example here and imagine, I mean, this is a little bit redacted, but it's very similar to an actual case that we did a little while ago. You know, there was an alert, a different tool decided that, you know, there was a suspicious execution, some command line actually launched. This was actually a scheduled task that ran, and it actually had installed the service and started it. It's telling us this command modifies a service named whatever to automatically start, and starts it. So this is suspicious, right? So now when we get this alert, I would actually create a new notebook. Just click on this plus thing here, and you know, fill in the details. I've done this before, and then I would typically, you know, maybe take a screenshot of this is what I did here of the case. And the first thing that I'd like to see is, you know, obviously we're going to look for scheduled tasks, but there's also a bunch of execution, and you know, we might have some evidence of execution. So there's a bunch of different evidence of executions. Of course, we'll do a lot more than that. But let's say that in this example, let's say that we just want to look for prefetch, which is just one sort of evidence of execution, so the prefetch files. So instead of thinking about, oh, you know, maybe we are, let me just go over here. Let me just look in here. So here's, so I've collected the list directory before, but now I can actually click the prefetch. So I would click a different artifact, just select the prefetch artifact, and you know, I might decide to choose some kind of a timeline, add it, right? And the whole point of these artifacts is that the query itself is in a YAML file and it's built in, so I don't need to really know what the query is. You know, it's been contributed, it's an open source project, so everybody can contribute to it, and we build a community with them. I'll show you a little bit later on how we exchange VQL artifacts as well. And it, you know, artifacts take some, you know, parameters in here, and we can see that's the source, which is the actual query that's going to run. And then when we have a look, we can actually set date after, date before. You know, like let's say that, you know, we want to have, we really want to know anything after, you know, maybe January 1st, and you know, we might actually here restrict the binary to se.exe, you know, because it might be because we want to look at just evidence of execution of SC, and then, you know, we just go ahead and do that thing, and it basically immediately issues this thing to the endpoint, and the endpoint is always connected, so we just pick it up, off we go, it starts to run. So if we have a look at the log, then it says, okay, starting query execution, I sent you back 12 rows, done. So it's basically gone through, it's looked through all the PF files, the prefetch files, parsed them out, and then sent back all the events that were, you know, occurred after January 1st. And so when we look at the results here, then, you know, we have a bunch of stuff, but you see that we accidentally got some other things here, and some other things are not really super related, but that's pretty good, right? So usually, you know, the prefetch would be hundreds and hundreds and hundreds of lines, right? So and in this case, we're coming back with only 12 rows, and so it's much more targeted. So let's go back to the notebook, and what I might do is I might just open it here in another tab, so I don't have to keep switching, but that's okay. And you can see that notebooks are consisting of cells. So this is very similar to something like Jupyter. You just have cells, and a cell can simply be Markdown, which is this kind of cell, or it can actually be VQL. And with VQL, we can just write a query directly. So I'm just going to write a query, a VQL query here, and it comes up with sort of an editor, so I can type the VQL in. And just to save time, I actually have it copy pasted from here. So I'm just going to cheat a little bit. This one. Oh, this one's actually not VQL. It's the Markdown one, but I'll change it here. Oh, sorry. Do that again. Copy. Just change it to Markdown. And this is basically looking at the prefetch results. So just to save on time, I copy pasted it, but I would normally just type that in. You would copy paste it from another thing. This is a different client actually. Edit this. And then I can just change the query where file name, and this one is the regex match command sc.exe, and we'll just do it hat, so it will be exactly that, for example. And so what that does is it basically will restrict us, and we can see like a timeline type thing. So the idea with this notebook is that it just builds up this timeline of, in this case, we're working through our analysis. So we can actually go ahead and type the reasoning for it and so forth. The next thing that I'm going to do is that I know that this that this was a problem with scheduled tasks. That scheduled tasks actually ran. So I'm going to do a hunt. So this is the hunt manager. A hunt is basically a way of running this scheduled task everywhere, this artifact collection. So we're going to collect this from everywhere. Before, we only just collected the prefetch from that one particular host. But let's say that you had 5,000 machines or 10,000 machines. And so we want to collect the scheduled task from all of these machines at once, right? So we can just do the same thing. But this time, we're going to collect the scheduled tasks, which is this one. So as you guys know, scheduled tasks is a directory in Windows where there are XML files which basically tell you, the task scheduler. So we're going to collect this thing, and it basically just pulls out these files and parses the XML out and just tells you all about them in this directory here. So we're going to do that as a hunt, which basically means that it would be from all the hosts. So we're going to give it a name, description, collect scheduled tasks, and then we're going to just run it everywhere. And when we create a new hunt, it's in the paused state. So we start it, and then off we go, right? So all of the machines that are actually running, you see one machine got scheduled, and then two machines get scheduled, and one's finished, and this will just go through. So typically something like this is very light. So collecting all the scheduled tasks will take maybe, I don't know, 2 minutes or so to do like 5,000 machines, so 10,000 machines, pretty easy. And so we can actually, but the problem is that if we look at the results, there's going to be a lot of results, right? So we can see, there's going to be, a bunch of results here. So we're going to go back to the notebook because we're going to work through them a little bit better, right? So we're going to need to post-process this data a little bit because it's just too much of it. So what I'm going to do here is I'm going to go to this cell and add a cell from a hunt. And essentially what this will do is it will create a new VQL cell, but just kind of fill it in with a VQL that makes it easy for me to use. So we're going to click that hunt. And when we click OK, then it's going to basically just populate this VQL with the right thing, right? So and it's got a limit of 10. So we're just going to, when we click save, we're just going to see the come on. we're just going to see the first 10 results. Oh, the demo code is not working. Try that again. Try that again.
All right, I think we have Ian to blame for that because I'm pretty sure he didn't sacrifice his bottle of rum today.
Yeah.
I thought we'd have enough time from yesterday to cover us over today. I'm very sorry.
No worries. Oh, maybe the server went down. I hope not. Let's have a look. Oh, it could have. Did it go down? No. Oh, it's all right. We'll try again. Yeah. Try again. So, oh yeah, here it is. So, okay, so this is what it's supposed to look like. Well, it actually did it. Yeah. So what it will show us is it shows us the first 10 rows from the hunt, and you can see that there's different columns. It'll be like the full path, the command, and the arguments. And there's actually more over here that's kind of cut off. So I'm just going to fully qualified domain name, the commands, and the arguments. So this first step is just to say I want to just see these 3 columns. I don't care about the rest of them. So it cuts it off, and you can see it's looking much better. Then I can say, okay, I'm only actually really interested in the ones where command matches cmd.exe, because I know that essentially the scheduled task is running the command shell in order to install the SC and all that sort of stuff. So I actually kind of cheated a little bit here because I created a scheduled task that just does a DIR, which is not malicious, but imagine this was the malicious command. But I'm just going through an example of an analysis of how you would do this. Is you basically now narrowed it down, so you got like a subset of commands that launch with cmd.exe, but you see there's a whole bunch of false positives here. This one's fine. These are all okay. So then I can just basically go and not, command matches, and this is the dsreg one, right? Which is actually okay, dsreg one. So then I filter them out again, and so you can see how when I go through that, I actually filter it out, and I was like, oh, this is the bad one. This is the and so typically, like we had a case where you have massive infection across laterally, they propagated across the network and just installed these scheduled tasks on literally thousands of machines, and so it was actually impossible to really clean that up in any manner, even if you had RDP access to the machines, and you can't just like log into thousands of machines and clean them up. It just takes a very long time, and by the time you do that, the bad guys can switch, right, and they can essentially remain persistent. So then we decided, hey, you know what, let's use this DFIR mode and let's do some remediation, right? So let's actually see if we can clean up these scheduled tasks. And so this is actually kind of an interesting idea, right, where we can do remediation at scale. So there is this artifact, and I'm just going to show you an example here real quick. Remediation. So then I just quickly wrote this artifact. And essentially, it's pretty simple. It's got a bit of a PowerShell snippet. And so we actually run through, there's a bit of a complicated VQL here. I'm not going to go into it too much. But essentially, it detects those PowerShell artifacts, those scheduled tasks that match the correct arguments and the command regex that we've identified as being the malicious one. So it's going to be cmd.exe, and then it's going to be anything that runs, dir is going to be our, evil command in this case. And then so it basically does the same thing, but then if it finds them, then it also runs this PowerShell snippet to, uninstall them. And then finally, there is this little button that says like, really do it, because we could do a whole bunch of damage if we just start uninstalling accidentally if these, regexes were too loose. So I'm just going to leave that off for the moment. It's going to be like a dry run type thing. And so I'm going to go like dry run of remediation, for example. So that's what I'm going to call my hunt. And I'm going to go ahead and do that. And I have to, start it. And so now what I'm going to do is it's going to go off and do the same thing, right? But yeah. So you see, it's scheduled to. It's going to finish in just a short time, and then we're going to have some results. But this time, I expect to only get the exact matches of those scheduled tasks. So before we just got all the scheduled tasks and we had to post-process them and narrow them down. But now we got pretty good with our signatures, and so we actually got very tight, right? So I would like to see here no false positives. And then when I'm comfortable without these false positives, then I'm going to go, okay, cool. So now let's do it for real, right? So now we're going to do a remediation. And this time, we're going to click the, so it's still going to be cmd.exe. And over here, anything contains DIR. And then I'm going to do, oh yeah, I just want you to really do that. Yeah, go ahead. And then, really do it. Really remediate. Okay, and click. Yep, it's a little bit clicky, the interface, but anyway. All right, and off it goes and does the thing. If we look at the overview again, we can see should see them being done. Okay, and again, it's actually going to actually run the PowerShell snippet, for us, and it's going to show us the same thing again. Sorry. Should be, but this time they should be completely, removed, right? So, so now, if we collect the scheduled task, yeah, next, and then we're going to do a cross check, right? So we're going to just check to see that, that worked. Okay, so off we go, start it, go, all right, and it's going to go off and do the thing. And we should be able to see that client scheduled. It's just so now we're just collecting flat out all the scheduled tasks, and we should not be able to see anymore these DIR thing. I mean, they should be gone, but we don't know that because we have to post-process that. So we can do that again. So we'll go back to our document, our working document. Not this one. So over here we've got, this will be the first example. Then what I'm going to do is just have some markdown, add a markdown, etc. from hunt, remediate. Okay, and then this one is, I don't know what's going on with this. Demo go, it's not working again. Yeah. Okay, add cell from hunt. We're going to do this remediation one. And when we save it, we should see, so this is just a way of us documenting it. Again, we only want the full path to command the argument, so not all of it. So we'll do that again. Full path, command, arguments. So, and then, in here I would go and actually add some explanations, in a bit of markdown and explain, what's going on here. So this is the, and then finally, we'll do the other hunt, which is the cross check. And in this one, it's going to be the same thing, full, full path, command, arguments. And then we can do, where command matches. So it's the same thing as before. And we're going to look to see, and you can see already they're not there, right? So those DIR ones, they've been removed, right? So that's the cross-check step to say, like, yeah, this is pretty good. This is how it's supposed to be. So this is basically, what I call DFIR, beast mode. You basically just kind of like run this, and this is, really, really effective doing this kind of remediation. I mean, it's kind of risky because that's why we have to test it, make sure that it's, going to do what we expect that it does. But sometimes it's very effective when you have a lot of machines to clean up. So it's kind of interesting. I just wanted to show you guys how to do the analysis and the post-processing. This notebook feature is fairly recent. It's only come up in the last couple of, I think, 2 releases. And the nice thing about it is that we actually can download it offline and create an export. And that essentially makes a point-in-time export of that worksheet, the notebook. And so because normally in a DFIR case, things change really quickly, and what we know today is not the same as what we know tomorrow. We find out new information, we build new knowledge. And so that notebook is kind of like a living document of how we're doing and what we actually know at each point in time. So you can produce multiple versions of it. And these are actually supposed to be standalone. So you can actually just open those. The zoom is getting in the way too much, and you can see that it's basically it just lays it out a little bit differently, so it's non-interactive, but it's kind of like a document. You can print it and these kind of things. So the markdown shows you it's kind of like a document kind of thing. So we can we can use that to kind of keep track of reasoning as we go along and do that sort of thing. Yeah, so I think that's kind of all we have time for today, right? Because I mean, we are kind of up to the time, right? So yeah, there is a lot of functionality in here that I can't cover in 30 minutes. There's far too much. Check out the website. Oh, over here, I forgot to show. This is our GitHub. You can just jump on the GitHub, download it. We have releases and so on. There is a wiki as well, and in the wiki we actually have these custom artifacts library where people can just exchange artifacts for different things that just knowledge sharing in a sense. And then of course it's open source, so you can obviously submit the artifacts as PRs so they can go back into mainline. But these are basically something that people find useful on certain jobs, and may not be for everyone, but it's very useful. So for instance, this particular one, I just wanted to quickly say, this is one we used on a previous job, but we had a domain admin account that was compromised, and we wanted to know what actually did they do as that domain admin. So of course, you have your normal remote login type event logs, but we decided we actually, there's a lot of event logs that are actually not known, and we have no idea because they're depending on the application. And so there might be an application that this user is actually like logged into on a remote machine, like maybe Exchange or whatever, right? But we just don't know. So this particular artifact, as you can see, it basically looks through all the event logs, it parses them all out, and then at the EVTX it parses them out, and then it basically looks for either the seed or the name of the user, and so if any event, like we found like schedule, like bits transfer or even Chrome update type thing, that just had that username in it. And if it's a domain admin that's not often used, then this is really good because you can narrow it by time, and you can basically find any kind of related event logs from other applications that could actually give you clues as to what was going on with that account once it's been compromised. So it's really useful. So this is kind of an example. I like this because it's kind of an example of using something like a blunt sledgehammer kind of thing like Yara to say, we're just going to take Yara, it's just a big grep, and just look for, and it gives you really surgical results, because once you get an event log entry, not just the whole log, but just that particular entry that actually matches that Yara sig, then it actually automatically becomes relevant, and so you get like really good value out of that. So that's an example of the flexibility that you can get by having these forensic analysis on the endpoint. Okay, so I think that's all I have time for. Thanks for watching, and take care, everyone. I'll answer the questions in the Slack as well after this.
Thank you so much, Mike. This presentation makes me really happy. Velociraptor is an amazing tool, and we'll give you a little plug on the fact that you do training. I know you had an in-class training. Did that go ahead?
Yeah,
yeah.
we were actually super lucky because our training was like the week before everything went, you know, south. So we just got it in, and then you know, yeah, then everything went south. So hopefully we've got one scheduled in November. So hopefully it will be okay by November. I'm really hoping so.
Well, virtual is still a really good option as we're kind of learning this weekend. But yeah, and check out I posted the Medium blog in the chat channel as well, because I've noticed you've been pretty active recently.
Cool. Thank you very much. Thanks.
Awesome. Thanks so much for joining us.
Thank you.